Hello everyone and welcome to the lecture on Amazon MemoryDB for Redis. So this lecture will contain all this topic. What is MemoryDB for Redis? Features of MemoryDB, core components, MemoryDB for Redis versus Elastic Cache for Redis, understanding MemoryDB replication and replication in a cluster. So what is MemoryDB for Redis? MemoryDB for Redis is a database service that provides durability and stores data in memory for fast access. By storing data in memory, MemoryDB delivers microsecond read and single-digit millisecond write latency along with high throughput. MemoryDB is designed specifically to cater to the needs of modern applications built using microservices architecture. MemoryDB is compatible with Redis, a popular open source data store, allowing developers to use familiar Redis data structures, APIs, and commands. All data in MemoryDB is stored in memory, enabling lightning fast performance and low latency. MemoryDB ensures data durability by storing data across multiple availability zones using a multi-AZ transactional log, enabling fast failover, database recovery and node restarts. With its combination of in-memory performance and multi-AZ durability, MemoryDB can serve as a high-performance primary database for microservices applications, eliminating the need to manage a separate cache and durable database. Features of MemoryDB: strong consistency for primary nodes and guaranteed eventual consistency for replica nodes. Microsecond read and single-digit millisecond write latency with up to 160 million transactions per second per cluster. Flexible and friendly Redis data structures and APIs. Easily build new applications or migrate existing Redis applications with almost no modification. Data durability using multi-AZ transactional log, providing fast database recovery and restart. Multi-AZ availability with automatic failover and detection of and recovery from node failures. Easily scale horizontally by adding and removing nodes or vertically by moving to a larger or smaller node types. You can scale write throughput by adding shards and scale read throughput by adding replicas. Read after write consistency for primary nodes and guaranteed eventual consistency for replica nodes. MemoryDB supports encryption in transit, encryption at rest, and authentication of users by authenticating users with access control list (ACLs), encryption in transit with TLS, and encryption at rest with AWS KMS keys. User authentication and authorization with Redis authenticating users with access control list. Automatic snapshots in Amazon S3 with retention for up to 35 days. Support for up to 500 nodes and more than 100 terabyte of storage per cluster with one replica per shard. Support for AWS Graviton instance types. Integration with other AWS services such as CloudWatch, Amazon VPC, CloudTrail, and Amazon SNS for monitoring, security, and notifications. Fully managed software patching and upgrades. AWS Identity and Access Management IAM integration and tag-based access control for management APIs. So the core components. First, clusters. A cluster is a collection of one or more nodes serving a single dataset. A MemoryDB dataset is partitioned into shards, and each shard has a primary node and up to 5 optional replica nodes. A primary node serves read and write request, while a replica node only serves read request. A primary node can fail over to a replica node, promoting that replica to the new primary node for that shard. MemoryDB runs Redis as its database engine, and when you create a cluster, you specify the Redis version for your cluster. Next is nodes. A node is the smallest building block of a MemoryDB deployment and runs using an Amazon EC2 instance. Each node runs the Redis version that was chosen when you created your cluster. A node belongs to a shard which belongs to a cluster. Each node runs an instance of the engine at the version chosen when you created your cluster. If necessary, you can scale that node in a cluster up or down to a different type. Every node within a cluster is the same node type. Multiple types of node are supported, each with varying amounts of memory. Next is shards. A shard is a grouping of 1 to 6 nodes, with one serving as the primary write node and the other 5 serving as read replicas. A MemoryDB cluster always has at least one shard. MemoryDB clusters can have up to 500 shards with your data partitioned across the shards. Parameter groups. Parameter groups are an easy way to manage runtime settings for Redis on your cluster. Parameters are used to control memory usage, item sizes, and more. A MemoryDB parameter group is a named collection of engine-specific parameters that you can apply to a cluster, and all of the nodes in that cluster are configured in exactly the same way. Subnet groups. A subnet group is a collection of subnets, typically private, that you can designate for your clusters running in an Amazon Virtual Private Cloud environment. When you create a cluster in an Amazon VPC, you can specify a subnet group or use the default one provided. MemoryDB uses that subnet group to choose a subnet and IP addresses within that subnet to associate with your nodes. Access control list. An access control list is a collection of one or more users. Access strings follow the Redis ACL rules to authorize user access to Redis commands and data. Users. A user has a username and password and is used to access data and issue commands on your MemoryDB cluster. A user is a member of an access control list ACL, which you can use to determine permissions for that user on MemoryDB clusters. MemoryDB for Redis and Elastic Cache for Redis. So MemoryDB for Redis we are talking about, but there is one more service which is Elastic Cache service, and it has Elastic Cache for Redis version also. So there is Elastic Cache, Memcached, and Elastic Cache Redis. So Elastic Cache is its own product, but MemoryDB is a separate product for Redis. So we'll see what is the difference when we should use. So this is versus. So we'll do a comparison when to use what. So MemoryDB for Redis is designed as a durable in-memory database for workloads requiring an ultra-fast primary database solution. So it works as a primary database and highly durable. MemoryDB provides microsecond read and single-digit millisecond write latency, making it suitable for application demanding high-speed data access. MemoryDB allows you to build application using familiar Redis data structures and APIs while ensuring data durability, making it a good fit for use cases requiring a primary durable database. So the important keyword for a MemoryDB is it's like a primary database. And by using MemoryDB, you can simplify your application architectures and reduce cost by replacing the usage of a database with a cache for durability and performance. So because it serves as a single database plus cache service, so basically it simplifies the whole architecture. So this was about the MemoryDB. So let's see what is how Elastic Cache differs. So Elastic Cache for Redis is commonly used as a caching service to accelerate data access from other database and data stores. So this is the secondary component. This is something which you add to your primary database. So database can be your MySQL or any other database, but Elastic Cache will be served only as a caching service. Elastic Cache for Redis offers microsecond read and write performance, making it suitable for caching workloads where you want to speed up the data access with your existing primary database or data store. So speed wise both are like quite fast, but this is as a secondary database, only as a caching service. And Elastic Cache for Redis is a good choice for use cases where you want to leverage Redis data structures and APIs to access data stored in a primary database or data store. So this will result in bit complicated architecture because you will have one more database, and this will be, so your application code will have to like factor in that there are two databases and one is used for cache and another for primary storage, or the main storage. So next is MemoryDB replication. MemoryDB implements replication with data partitioned across up to 500 shards. Each shard in a cluster has a single read/write primary node and up to 5 read-only replica nodes. Each primary node can sustain up to 100 megabyte per second throughput. You can create a cluster with higher number of shards and lower number of replicas, totaling up to 500 nodes per cluster. This cluster configuration can range from 500 shards and 0 replicas to 100 shards and 4 replicas, which is the maximum number of replicas allowed. Replication in the cluster. So each read replica in a shard maintains a copy of the data from the shard's primary node. Asynchronous replication mechanism using the transaction logs are used to keep the read replicas synchronized with the primary node. Application can read from any node in the cluster. Application can write only to the primary nodes. Read replicas enhance read scalability. Since MemoryDB stores the data in a durable transaction logs, there is no risk that data will be lost. Data is partitioned across the shards in a MemoryDB cluster. MemoryDB clusters are regional and can contain nodes only from one region. To improve fault tolerance, you must provision primaries and read replicas across multiple availability zones within a single region. So it's a regional service, but to improve fault tolerance, you should consider spreading it across multiple availability zones within a single region. And that's all. Thanks for watching.